All right, guys, so the first two problems that we're going to go over here deal with where we are just looking at one radical. So if you want to pause the video real quick and take a second and copy this down, these notes are going to be helpful today for your practice problems that you have. So go ahead, pause the video, and then take a second and write these problems down. All right, guys, so taking a look here at these two problems, before we get started, I first want to remind you that when we're solving for x, anytime we're solving for x, it doesn't matter whether we're dealing with radicals, linears, quadratics, anything, we want to solve this by doing the opposite. So addition and subtraction, multiplication and division. And then as a reminder, radicals are opposites of exponents. So remember this little number right here is called our index. So say we have an index of 3, I would want to raise it to the third power to undo that radical. Just like if I had, like for example, x squared, to undo x squared, I would take the square root. Okay, so those are opposites of each other. So let's go ahead and look at this first one. We've got 2 times 3, the square root of 3x plus 7. And then this minus 1 is on the outside equal to 7. All right, we want to go ahead and first focus on, I want to get this radical right here by itself. So this minus 1 and this 2, we want to move away from that first. So I'm going to do that first by adding 1 to both sides. So I get 2 times the square root of 3x plus 7 equal to 8. And then I want to go ahead and undo multiplication with division. So I'm going to divide both sides by 2. So then I'm left with the square root of 3x plus 7 equal to 4. So again, my first step here was focused on getting this radical by itself. Anytime you have something outside of the radical like this, whether it's multiplication or addition or subtraction, before we can undo a radical, we need to get it by itself. So I'm going to go ahead, and that's why I moved those first. All right, now we have the square root of 3x plus 7 equal to 4. Now, as we look at our x value, I can see that it's underneath this radical. So I need to go ahead and undo my radical by raising this side to the second power and this side to the second power. So then I get 3x plus 7, right, because my squared and my radical cancel, equal to 16. And then this is a very simple algebra problem you guys have been doing since freshman year. And then we're going to go ahead and solve for x. So I'm going to subtract 7. So I'll get 3x equals 9. And then divide by 3. So I get x equals 3. Now, the very last thing you want to make sure you do is to check your solution. Okay, we want to make sure that it is true. We want to make sure that it is true. So I'm going to go ahead and take 3, and I'm going to go all the way back to my original problem here, and I'm going to plug 3 in for x. So I've got 2 times the square root of 3, my new x value here, I'm going to go ahead and plug in plus 7, right, all underneath my radical, minus 1 equals 7. So I want to go ahead and I want to make sure that this is true. So when I plug in 3 here, what I mean is when I type this all in, I want it to equal 7. And I'm just going to use my graphing calculator here. You might have one at home, you might not, but either way, you can use your calculator on your phone as well. So square root of 3 times 3 plus 7. And then I need to close my parentheses because that's underneath my radical there. And then I'm going to go ahead and hit minus 1 for my equation there. And I do get 7. So what I got over here is I got 7 equals 7. That's true, so I know x does equal 3. All right, we're going to look at one more problem here together. Very simple problem. I am dealing with one radical and I want to get x by itself. Remember, anything outside of our radical we need to deal with first. So this dividing by 7, I need to undo division by multiplying both sides by 7 here. So this cancels on the left and I'm left with the square root of x plus 9 equals negative 49. Undo your radical by raising both sides to the index here. So I'm going to raise both sides. Careful, that negative is still in there. To the second power. So my radical and my squared cancel, and I'm left with x plus 9 equals, and then when I do negative 49 squared, see how I put my negative 49 in parentheses? Very important. I get 2,401. I'm going to go ahead and subtract 9. And so I get x equals 2,392. And again, I want to check to make sure that my solution is true, that it works. So I'm going to go ahead and replug this back in. So the square root, my new x value here is 2,392 plus 9. Scooch that up for you. When I divide that by 7, I want this to equal negative 7 here. So let's go ahead and use our calculator. So square root of 2,392 plus 9. I'm going to go ahead and press enter. And then when I divide that by 7, I get 7 on this side. Now let's take a look here. 7 does not equal negative 7. This is not true. So this cannot be a solution. We have actually here what's called an extraneous solution. Or you could also say no solution. Okay, you need to make sure you're checking your answer every single time, because sometimes it's going to work out like what we saw here on the left, and sometimes it's not. All right, guys, go ahead, use these notes as a guide to help you on the practice problems for today. We are just dealing with one radical today for our practice problems.